Hi, this is episode 5 of MickMake Mates tutorial into Arduino Programming. In this episode, we'll be covering a continuation of episode 4's tutorial, creation of an Uber project which combines 3 Arduino tutorials, button bounce and various ways to solve, and capacitors. I apologise for the lack of gag in this video. I've been very sick this week and so I haven't had time to do it, but maybe next time I might do 2. This first part is a continuation of the analog tutorial from episode 4. Okay, so Tim,
Yes.
we've got the Arduino analog input SketchUp and we've just programmed it.
So just to go over the pins we're using.
Tracing it back, we can see it's connected to the middle
of the pot.
The middle of the pot.
Okay.
And we've got the ground connected to the other side.
Yep.
And VCC connected to the other side. So you remember how it was a voltage divider?
Yep.
Theoretically, when we change this, it should change the pulsing rate of the LED, which it does.
Yeah, so slow to fast.
So really slow all the way up to really fast, so fast that it's not even delaying at all.
Yeah, okay.
So that's good. With the pot turned this way, it's applying, what have we got? That one's connected to VCC, so there'll be the VCC, so there'll be a long delay, moving down gradually down to 0 volts.
That's less resistance, you mean? Or?
That's right, which we know.
Oh, hang on a second. It's not really resistance, is it?
Well, it's resistance you're adjusting, but it's a voltage divider that you're adjusting.
Yeah. So the Arduino is not measuring resistance; it's measuring volts, which you're changing via the Arduino. Okay, yeah. So 3.3 VCC.
Yep.
3.3
so
volts.
That's 3.3 volts, which is the highest delay that we've got.
Yeah.
And as we gradually reduce it down to 0 volts on that pin.
Okay. So you could use this to change the speed at which a motor runs, maybe.
Yes,
Yeah.
you could.
So you have a slow motor or a fast motor. You wouldn't obviously power it directly. You'd use a transistor of some sort.
That's right, yeah, a power transistor. Now we get to the interesting part. I give Tim a special project which combines 3 of the Arduino tutorials into one. This will give him a good grounding for his project goals and extend his understanding of Arduino programming further. So Tim, because your ultimate goal is to create an automatic nerf triggering thing, this is the next thing I want to get you to do. I've built this and already coded it up, but I actually want you to be able to get to the stage by the end of the session that you've done it as well. So don't look at don't cheat there.
Yeah, okay. So this is the code.
That's code. I've programmed it up and I've got a button here and I've got a potentiometer here, and what the potentiometer does is it adjusts the firing rate.
Yep.
So the firing rate is determined by the LED on the teensy.
Okay. What's that green light for?
The green light shows you the delay in the pulses.
Okay.
So when you press the trigger button, which is this one, it'll fire 6 pulses, and the delay is determined by this. So if I press this button, you'll see the LED fire. Now at the moment it's very, very slow.
So it's perceptible. Yeah.
Yeah. So if I increase it slightly, and you'll see as I increase it, you'll see the one way. You'll see the LED go out.
Yeah.
So when it's dark,
yeah,
it's a very, very short delay.
Okay.
So if I press it again, you'll see the pulses. So you press it once and it fires six darts.
Yep. Okay. Yep.
If I hold it down, it just keeps firing.
Oh.
Right? And so you adjust the rate. As you adjust it, it brightens and it slows down. If I double tap it, it still does the 3 darts.
Okay, 6. Yep.
Yeah.
Okay, cool.
6 darts.
Yep. Okay. Oh yeah.
Tim wasn't particularly excited about that, was he? Tim didn't really know where to start with this project. When facing a seemingly complicated task or project, it's better to break it up into smaller sections or chunks. This is called blackboxing and really works for pretty much everything in your life. The next part, we take my sample project and start to move components over one by one. The first black box that we need to get right is of course the button. So there's several components. One, you need a button. So if you open up the button sketch, the basic button sketch.
What do I find button? Basic?
Yeah, basics. Digital button. Yep. Now go up to File and then Save As, whatever you want to save as, Timothy or whatever.
Tim Button.
Tim Button.
Okay.
Right, so this is a good starting point. So I've got the button configured to pin 22.
22, yep, okay.
So if we change that to pin 22,
button pin 22.
Yep.
Yep.
And then what we'll do is we'll take components off my side,
yep.
and I'll attach it to your side and see if we can get the same result. So take the button out.
Okay. So grand and 22, right?
Yep. Before we do that, let me just unplug it just so we don't short anything out.
So ground is this last one.
So you also need to take the pull-up resistor. Yeah, this from last week. It was very important, wasn't it?
Yep. So
we've got a pull-up resistor here. That will go from VCC to that pin.
VCC is 3 down.
3 down. Yeah.
Okay.
Alright, so let's just fire up that code, program the Arduino and see how it goes, and that should be fine. So if we press the button and it does what it is.
Alright.
Now, there's one other thing with buttons, and I need to explain it. Handling a button isn't just a simple case of reading its current state and responding to that input, as we'll find out in this next section. We have to deal with button bounce. Let's see what that is and how to deal with it. When you press a button down, it doesn't go down straight away.
Yep.
So there's a thing called button bounce. A button is basically 2 bits of metal. When you press the plastic down, it pushes and makes contact with these 2 wires.
Yep.
If you've got that little section and you zoom in microscopically, it's not parallel.
Yeah, it's not perfectly straight.
Not perfectly straight. And there's also pits on the surface.
Yep.
So as you push the button down, that'll suddenly arc across.
Yep.
So you've got 2 bits of wire, and if you apply a big enough voltage, you'll get a fairly decent arc.
Yeah, like a Jacob's ladder in
that's
Questacon.
right. If you reduce that down to a microscopic level,
yep.
then you can still get arcs.
Yep.
So we're talking 3.3 volts. And if you can graph out exactly how that looks, this is a graph of voltage over time. In this case, we've got a pull-up resistor, haven't we?
Yep, so it's always high.
So it's always high. This scale here is, say it's milliseconds.
Yep.
Because of these little pits and grooves and arcing that happens, you'll see that press like this. And this is you pressing it as fast as you possibly can.
Yep.
Now remember how we have the pull-up issue. So the same issue occurs. So we've got a voltage threshold.
Yep.
Which is usually a third either side. As you can see, if you actually run through this at certain times and apply a logic level, depending on whether it's
on
high,
or off.
on off.
Yep.
So that's a logic 1.
Yep.
This is probably an unknown state, but internally it'll say it's a 1. That's a 1. This is a 1, but then when it just drops down to here, it becomes a 0, and that's a 0, and then suddenly it becomes a 1, and that's a 0 and 0, 0. So your single button press that you've done now turns into 2 button presses, effectively.
Or multiple,
multiple button presses. That's called key bounce, especially in your case. If you don't deal with this key bounce problem, if you've got a trigger and you press it, you don't want darts to be fired when you don't want darts to be fired.
Yeah, because when I pushed the button, it was fine. It was off and on.
So when we're pressing the button, the action of pressing the button is milliseconds. Now, I'm just trying to hold it down very slightly.
Yeah.
So you can see it's sort of pulsing on and off. So that is bad, and you need to deal with that.
Okay.
So fortunately, the Arduino IDE has a tutorial called debounce.
Does that mean that every Arduino code that incorporates some sort of mechanical switch has to have some sort of...
Yes. It has to have some sort of debounce. Actually, I'll tell you another way of solving debounces. So, you know what a capacitor is. Essentially, a capacitor will store a charge. So you apply a voltage across it, and all the electrons will sit there happily on one side.
They'll crowd up.
Sort of like a battery, sort of. We can make use of this. If we apply 3.3 volts to this point, and it's ground, then effectively for a short while we'll have 3.3 volts on that terminal.
Before it jumps across.
Yeah, so one way of solving is to make use of a capacitor to reduce the bounce. So going back to our...
voltage and time?
Yeah, going back to our voltage and time. What the capacitor does is it stores a charge. Any fluctuations in charge, it will have this sort of lag. This sort of bumpiness that we'll see will end up being something like this instead. So given a high enough capacitor. The problem is that if you have a capacitor too high, then coming from 0 to VCC again, you could potentially have a very slow delay. There's a fine point where it works and it doesn't work.
Because it'll slow down your project.
Yeah, that's right.
Okay.
Yeah, it'll make the button too
That's
laggy.
Like farads, right? If it's too many farads or microfarads?
So capacitors are measured in farads, and usually for a key bounce you'd be looking at something like maybe 100 microfarads, somewhere around there. But look, we've got Arduinos, just do it in code.
Yeah, I know, because I'm an electronics person, and Coding is quite difficult. I'm very tempted to just go down the electronic route and not bother coding. I mean, this is just for an up and down. It's just to push one button down. You got to add like 20 lines of code.
Yeah. Arduino, you can actually download a library that deals with that. So all you do is just call a function.
Oh. Okay.
And you don't need to worry about this.
Oh. Okay.
So,
so it's like a preset package you can shove in.
Yes. You just download the debounce library, and it just handles everything for you.
Okay, I think we'll do that next at some point. Yeah, for sure.
Thanks for watching episode 5 of Arduino Programming. In episode 6, we'll be seeing what a difference the debounce code actually makes, and taking the Uber project a little further by adding components of the analog tutorial. Until then, see you next time.